Okay, what is the cross product? Cross product is the x that you see in between those two vectors. This is what we say cross product. Okay, this vector times that vector, this magnitude of a first vector times the second magnitude of the second vector, but this time around we're using sine instead of cos, which is for the dot product. Since we're working with cross product, and then times the unit of the resultant. Okay, we could also say, just to facilitate this, we could say this the cross product equal to the vector c. Okay, and then we can just represent it in this form. So magnitude of c, which is based on these two vector, times unit resultant. Okay, and this is how you get your unit vector. It's actually equal to vector over magnitude vector. Okay, and then this is where you go to vector, magnitude, and then direction. This is actually the direction. If you have to find which direction we're moving, you go with this. This is how we're able to solve this direction. Okay, and as we saw, the unit vector is actually this one, not that one. This is actually a vector for direction. Let me correct that section where I say that. So to be right, this is the unit vector. So it's vector, this one, over the resultant equal. So we know already the vector resultant is going to be a function of all of this. Okay, so and then over the resultant. This formula we're going to use quite often. We use very often this formula. Bear in mind. And then you are tasked to find what is Rx. Rx is actually, since we have two vectors, so we have A and B, that's why you see x, b, negative x1. You take the final vector, so b, negative the first vector. So this is how we are able to solve it. So whenever you have two vectors on cross product, now ry is yb negative ya, z rz equal to zb negative za. Okay, so these are the formula that we're going to use. We can, after you solve them, then plug it them back inside the unit vector equation function. Okay, so this is cross product for us. We're going to tackle this chapter. Okay, let's just continue further on. You can see one example where we can get some formulas. So if you have to find resultant of AB, so we're working with AB. So this is the formula that you can use. So it's going to be XB minus XA I J K. This is how you're going to solve. This is a 3D since we have X, Y, Z. So Z, X, Y, that's what you see. So we want to find them between those 2 points. So this is where we have our A, and then this is where we got our B. So it should be what we got at B negative what we have at A. So XB minus XA, YB minus YA, ZB minus ZA. And then you got your resultant there equal to resultant, the unit resultant equal to the vector resultant of AB. So this is RAB vector that we're going to use into this formula, and then you got you need to find your resultant. Okay, so if I must tell you what is the resultant is actually xb plus xa squared. So remember that we saw early. This is what you could get for a resultant, plus square plus yb plus ya square plus zb plus za square. This is your resultant. And then we got another section where you can see this is what you get for the first one. Let's see this section. This is where you can see the cross product. This cross product. You could also represent them using this matrix. Okay, where you put ax, bx, ay, by, az, bz. This is a cross product you see represented with j, I, j, k. Okay. And then if you have to solve this matrix, you're going to solve them according to I. This is according to I. So you're going to times this one and that one, so that we see A times BZ negative A times BY. That's what you see there. And then you're going to continue further, and then you're going to solve them according to J. Just repeat what we say. So it will be A, B, AZ, BZ. So it's going to be AX times B, BZ. And then negative BX times Z. That's what you see here. Okay. You will do the same for J. Okay. And then you're going to have this one. So it's going to be AX times B. That's what you see here. Negative bx times y. This is what you see there for k. And then since we're working with k, and then the one this is what you're going to get for your final solution. Okay, this was just to give you an idea of how you can get you can use a cross product. This is how you can solve for the cross product. Remember, this is for C vector. This is how you can apply cross product between A vector and B vector. This is actually simple and quick, fast. So we can solve for this value. We're going to use this formula later on with some example. And then what you should know, this is when you work with 2D. Now it's still 3D. This is just to give you an idea. I times K, okay? I times J equal to K. Just this is one of the formula you should know. And then to prove those formula, it's what you just did here. If you take AI, you put it inside. You place the value of all this value, AY, BZ, AZ, BY, and so on. You replace them by this value, because you're going to end up with K. So this is going to give you K. That's what you see. We're actually representing them like this. And then this is also another rules you should know. When you move to I towards J, your answer will be K. Okay, this is like something that you should remember. And then if you go the other way around, okay, for this side, if you move J in the opposite direction times I, I'll get K. J times I, I'll get negative K, because I'm moving in the opposite direction. Okay, these are the other formula that you should know. So just to give you an idea. So this is what we did on dot product and cross product.